making them is a feat of precision engineering. Deep below the football field of the University of Arizona is a high-tech mirror lab, where glass blocks are melted in giant furnaces at over 2,000 degrees Fahrenheit, the temperature of volcanic lava. The hot liquid is spun into super smooth curved dishes. The 20-ton discs of cooled glass are then ground to within fractions of a human hair to make the precise shape. It is only when a thin film of aluminum is applied, only 100 nanometers thick, that the glass dishes become mirrors, like those of the large binocular telescope in Arizona. At 28 feet wide, these mirrors are 64,000 times the size of Isaac Newton's first mirror. And they can collect light from stars billions of light years away. In Isaac Newton's day, making large mirrors exactly the right shape is far too difficult. It will be a century after Newton before a new pioneer picks up his revolutionary design and transforms it. That man is musician and amateur astronomer William Herschel. Herschel has great ambitions. He wants to use a larger version of Newton's reflector to see further into space than anyone before.
Herschel is a musician. He's not an astronomer. He's a clarinet player. He's an impresario. He's a composer. But his real passion isn't music, it's astronomy.
Herschel wants to look anew at the night sky. He wants to look beyond the planets to the stars, and to see the very faintest stars invisible to other telescopes of the day. Herschel needs big mirrors.
He builds telescopes that are bigger than other people's because he realizes that the wider his aperture, the more light he can collect, the further he can see into space.
Making large curved mirrors, though, is still a major technical challenge in Herschel's day. Glass mirrors have not yet been invented. Mirrors are still made of metal. So working in his basement, Herschel casts discs of a metal called speculum, a special mixture of molten tin and copper. These will become his mirrors.
We don't know what the neighbors thought of this mad fiddler burning the entire road down.
Casting the metal discs is just the first step. To become mirrors, the cooled flat discs need a shiny curved surface. Herschel painstakingly grinds and polishes the metal discs by hand into the precise shape needed to form an image.
This is the reflecting mirror, the most precious component in the telescope, made in metal by William Herschel himself, made by hand. He was like a craftsman, making something which required manual skill as well as intellectual effort.
This telescope, over 200 years ago, makes a revolutionary discovery.
Or perhaps a comet.
In 1781, Herschel peers night after night into the heavens. At his side, his sister Carolyn.
Following Delta Tauri,
She records all their observations and will become a prominent astronomer herself.
Her observations were critical.
She was one of his true secret weapons.
Then, on March 13th, Herschel sees an object through his telescope that they have never recorded before. A very faint star that seems to move against the backdrop of the other stars. This wandering star is a brand new planet, Uranus.
The planets have been identified since the dawn of written astronomy. And then suddenly you have this clarinet player, with homemade telescopes in his back garden. He discovers another one. The thing is utterly astonishing.
Uranus, with its own set of rings, is the size of 63 Earths. But no one has identified it before because it is barely visible with the naked eye. 1,900 million miles from the Sun, It is twice as far from the Sun as Saturn, until then the furthest known planet. Overnight, Herschel doubles the size of the solar system. The discovery sparks a frenzied hunt for planets. It is a quest that the world's most sophisticated telescopes continue to this day. The sun is setting on Mauna Kea, Hawaii. The giant dome of the Keck Observatory opens. Its 33-foot wide mirror turns toward the heavens. Jeff Marcy is one of the world's foremost planet hunters. He is using the Keck telescope to hunt for planets in solar systems beyond our own.
Well, when you look up into the night sky, you see all the thousands of twinkling lights. Those are stars like our sun.
Planet hunters like Marcy think that many of these stars could have their very own planets. But finding them is another question.
Your mission as a planet hunter is to find that needle in the haystack.
Telescopes only made a breakthrough as recently as 1995. They recorded a perfectly ordinary star wobbling minutely. There was some gravitational pull on the star, evidence of a planet they couldn't see orbiting around it. Exoplanet 51 Pegasi b.
The discovery of the first planet around a normal star, around 51 Pegasi, was an extremely profound moment for humanity. We now know, as a species, that there are other worlds out there.
Since then, teams of astronomers across the world have found evidence for more than 400 other exoplanets. But most discovered so far are gas giants the size of Jupiter, orbiting far too close to their suns to support life. And a planet that can support life is what the planet hunters are really after.
What we'd love to know is whether there are other Earths, habitable worlds out there, whether they are lukewarm with liquid water, having the vibrancy, the conditions suitable for life, and perhaps even intelligent life.
Looking for small rocky planets like Earth is a whole new ballgame. Cue a brand new NASA space telescope called Kepler.
And liftoff of the Delta II rocket with Kepler on a search for planets in some way like our own.
Kepler's 3-year mission is to find planets the size of our Earth orbiting other stars.
Vehicle's now going supersonic.
I think Kepler is going to go down in the history books as one of the greatest telescopes ever in the history of humanity.
Kepler's mission is to collect light from a field of 100,000 stars inside our Milky Way, looking for clues to other worlds. As the dust cover falls away, it begins measuring the starlight.
All that happens is you watch the star, and Earth happens to orbit in front of the star. It blocks a tiny fraction of the starlight on its way, and when it blocks that light, the star dims a tiny amount.
Kepler has already discovered several new exoplanets. It hasn't found an Earth-like planet yet, but astronomers believe it is only a matter of time.
I believe in the next few years we will have the first detections of Earth-like planets, places that you might indeed want to call home.
Though Kepler is looking at 100,000 stars, this is only a tiny patch of the sky. There are hundreds of billions more stars out there to search.
The hunt for exoplanets requires that we look at hundreds of thousands of stars.
So planet hunter David Charbonneau uses more down-to-earth technology.
The revolution has been to use Hubble telescopes to study the closest stars.
Using small robotic telescopes, he scans 2,000 stars that are far less bright than our own sun. This makes it easier to spot a small planet passing in front of it. And he has discovered a planet only 2.7 times the size of our Earth. a super-Earth. Importantly, it appears to be covered in water and have an atmosphere. At 400 degrees Fahrenheit, it is still too hot to inhabit, but it's a tantalizing glimpse of what is out there.
If we can succeed in finding habitable worlds, then that would have implications far beyond mere astronomy.
In a bid to find habitable planets, the professional astronomers are getting a little bit of help on the side.
Amateur astronomers are central to our understanding of planets orbiting other stars. The amateur astronomers are stationed, of course, all over the world. They have telescopes which are certainly large enough to conduct a survey.
Ron Bissinger is one such astronomer. He is following in the footsteps of William Herschel and his discovery of Uranus.
When I come up here every night and open that thing up, fire up the telescope, fire up the computer, I know the target star I'm going to look at. Everything is mine. That's my world alone. I may, for that night, be the only human being looking at that star.
He has a telescope advanced enough to help out the professionals.
Professional observatories cannot spend the time staring at one star night after night after night, but we can.
He too waits for the telltale dimming of a star's light, just one star at a time.
To find a world out there no one's ever known of or seen or detected before, from your own backyard, a person who is not a career scientist. I don't know of any other scientific endeavor where somebody like me or so many other amateurs can do that kind of thing.
Bissinger's patience has paid off. He has already discovered several large exoplanets of his own, though all are too close to their suns to support life. Like all known exoplanets, they orbit stars within our galaxy. We know today that this is a vast collection of stars in which our Sun, Earth, and solar system also reside. But just over 200 years ago, we didn't even know we lived in a galaxy. Discovering this just by looking at the stars would be a great challenge. In 1781, William Herschel is the man who takes the challenge on. To do it, he just needs a bigger telescope. He builds a reflector 20 feet long. With this, he is able to see more stars than any other telescope on Earth, and he observes one part of the night sky in particular. The strip of stars we call the Milky Way. This will be Herschel's key to the shape of our galaxy. On a clear night, the Milky Way is a majestic spectacle. A brilliant band of starlight arcing overhead. To the ancients, it looked like milk had been poured across the sky, and it's why the Greeks first called it the Galaxias Kuklos, or Milky Circle. It's from this we get our word galaxy. It fascinates astronomers to this day.
The Milky Way stretches across the sky from horizon to horizon. It's like a big band that goes all the way around us. And so from here on Earth, it's kind of like we're sitting on the hub of a wheel, and the Milky Way is a big tire all the way around us.
Looking through his telescope, Galileo was the first to discover that the Milky Way is made up of stars. But no one knows it as a galaxy. They don't even really know what its shape is. Finding this out now becomes Herschel's obsession.
What is the actual shape of the Milky Way? We're in the middle of it, presumably. What would it look like from the outside?
He gazes tirelessly at the heavens night after night, mapping the positions of stars.
Herschel is nothing if not passionate. He's a natural obsessive. But good for him, he does something extraordinary with this obsession.
Herschel maps the distribution of all the stars he can see in a great circle that cuts through the Milky Way.
He introduced into astronomy the technique of star counts and just counting how many stars can I see.
One direction you see very few stars, in another direction you see zillions of stars. And so he plots this distribution and comes up with a view of the Milky Way.
The survey takes over a year of precise recording. Herschel finally produces a map called the grindstone because of its shape. For the first time, Herschel sees that the Milky Way is more than just a strip of stars in the sky. It is a vast disk of stars, and Herschel believes this is the whole cosmos.
When Herschel made his map of the Milky Way galaxy, to him he was making a map of the entire universe.
The edges of this star disk are the edges of Herschel's universe. Inside it lies our solar system, our sun and our Earth. The amazing thing is that over 200 years ago, Herschel almost got it right. The most powerful telescopes on Earth and in space now reveal that Earth and our solar system lie in a spiral arm in the suburbs of our galaxy, dwarfed within a giant disk of 200 billion stars spinning together around a bright central bulge that hides a supermassive black hole. The Milky Way is so large that it would take 100,000 years traveling at the speed of light, that's 670 million miles per hour, to cross from one edge to the other. Now, a new telescope is about to see what more it can find out about our Milky Way. The Herschel Space Observatory. Bill Latter is a key member of the Herschel team.
Herschel will map the entire Milky Way galaxy in terms of how stars are formed, how stars die, and how the galaxy is put together.
After years of careful preparation, the finely tuned telescope is about to launch.
Launch is a violent thing. There's no other way to describe it. We light this candle, it shakes, we throw the thing out into space, and we only can hope that it all holds together.
1 million miles above Earth, the largest mirror ever launched into space is looking beyond visible light to wavelengths our eyes cannot even see. The far infrared. This means it can measure tiny fluctuations in temperature and see right through clouds of dust to give us the clearest images of the Milky Way ever.
The results were astonishing. What we're able to see with the Herschel Space Observatory are right into the cradles of newborn stars. We see something very different than we would with our eyes. If we looked at the same region in visible light, it would be full of stars. But here, in the infrared, we're seeing dust and gas that really make up the majority of material in our galaxy, and it's where stars form.
No other telescope is able to see the Milky Way in this detail. Stars in these regions of our Milky Way were invisible to William Herschel. Yet over 200 years ago, he can see more in the night sky than anyone before him. And as he maps the stars through his telescope, one great mystery remains. Thousands of strange objects that astronomers can't explain. They call them nebulae, Latin for clouds.
There are fuzzy patches of light that you can see in the sky. They kind of look like pieces of the Milky Way that have been detached, and a couple of them you can actually just see with the naked eye. But through a telescope, there are thousands of them, and they have all kinds of different patterns and shapes and sizes. They're quite beautiful and quite mysterious. One of my favorites is the Andromeda Nebula, which you can actually see with the naked eye. And through a telescope, find it here. It's really mysterious. You just see this glowing light that gets brighter and brighter towards the middle. It's like, what is that?
Herschel makes a catalog of these mysterious objects, counting and classifying over 2,300 nebulae. But even with his giant telescopes, Herschel can't tell what they are or where they are.
There were little smudges that you could see in the best telescopes of the day. Those smudges were thought to be nebulae, clouds of gas, but people began wondering how far away those smudges were.
The mystery of the nebulae will continue to perplex astronomers for decades. 60 years later, at Birr Castle, Ireland, the eccentric Lord Rosse builds the largest telescope in the world. He wants to finally crack the enigma of the nebulae. 6-story walls support a cube 60 feet long, and the mirror is the height of a man.
He's a natural engineer, and if you see the great Leviathan of Parsonstown, as it's called, this great 6-foot aperture telescope, it's a vast machine.
Lord Rosse points the telescope at the nebulae. He sketches what he sees. For the first time, the fuzzy clouds begin to come into focus. Inside some of them, Rosse can see stars and spiraling structures. But there is a problem. Rosse's telescope can only move up and down, and the mirror tarnishes easily. The giant telescope falls into disrepair. It will take 80 years, a great revolution in technology, and a telescope bigger than Galileo ever imagined, high on a mountain peak, for the mystery is finally solved. This great telescope on Mount Wilson, California, will reveal that the spiral nebulae, first sketched by Rosse, are in fact separate galaxies beyond our own. The universe will be blown wide open.
It completely revolutionized our idea of the scale of the universe. No longer will we just confined to the Milky Way.
Our galaxy, the Milky Way, will no longer be the only galaxy in the cosmos. It will become just one of hundreds of billions of galaxies, spinning within an inconceivably vast universe.
The introduction of telescopes to astronomy opened up an entirely new window on the universe.
The race will continue to build bigger and bigger.
Our technology has reached a point where we can build gigantic ground-based telescopes. We can launch huge space-based telescopes and see the most distant things in the universe.
The telescope is pushing forward the frontiers of our universe. So what will colliding galaxies billions of light years away tell us about our own Milky Way? And right at the limits of the cosmos, what will the afterglow of the Big Bang tell us about how our universe began?
Every time you try and explore a new part of the universe, we have these great discoveries and these great surprises.
Most surprising of all, telescopes will reveal that right now we can only see 5% of the universe.
Only a few percent of the total matter and energy content of the universe consists of things that we can see.
So what is the rest of the universe made of?
In many ways, we're at the beginning of our quest of discovery. We're learning about the major part of the universe we didn't even know existed 10 years ago.
Telescopes will point to an elusive and powerful force that is shaping the fate of our universe. Dark energy.
I think dark energy is the most mysterious thing we've ever discovered.
Telescopes are on the brink of a new era of discovery and exploration.
It's such an exciting future to think about all of the discoveries yet to come.
we are uncovering a universe we are only just beginning to understand, as telescopes that are bigger and more sophisticated than ever continue the hunt for the edge of space.
Next time on Nova, for the next generation of telescopes, a new quest begins. Can we see the invisible?
10,000 galaxies in that single spot.
Go back further in time.
We can actually deduce things that happened in the first trillionth of a second.
Reveal mysterious forces shaping the cosmos.
Dark energy is one of the keys to understanding the fate of the universe.
Watch the next episode of Hunting the Edge of Space.
Major funding for NOVA is provided by the David H. Koch Fund for Science, supporting NOVA and promoting public understanding.